Hi, my name is Charlie Martz. I'm really into roller coasters, and so this is my science fair project. It is simulating a roller coaster. So we have the start, which is up top, and the end, which is down at the bottom. They both start and end at the same height and the same place. Our tracks are the same length, but they have two very different shapes. If you'll notice, on this track, they both start almost exactly the same. The first change is right here. One track goes through while the other one comes around. They both take a quick turn. One is the right track. The right track, or track number 2, is on this side. It's going to come down. It comes through here. You'll notice it just does, we call this the vertical track because it comes and does a loop. It's a lot less turning and coming down slowly so much as it just goes, loops, and comes out. This is our other track. We call this the horizontal track, and track number 1. Track number 1 comes around down here, comes all the way around, does a quick turn at the bottom, and comes out. So no loops in this one, quick turn at the bottom, but it's sideways. So, so most people say if this one might take a little longer. We were testing to see, our hypothesis was that the tracks will take the same amount of time if we use 2 marbles of same size. Couple problems we had. First of all, we spent lots and lots of time just trying to make a track that worked. Lots of times the track would stop and we'd have to use a magnet. The marble would, let's say, come up to a loop and not make it over. So the marble will come up to the loop, not make it over. So we'll have to take the magnet, hook it to the marble, and bring it over the loop, and then take the magnet out, off the track, so that the marble can keep going, so that we can get the marble out, so we could edit the track and make it work better. Another problem, the reason this was such a problem is because of sliding friction. Our marbles, when they're going, normally we just deal with rolling friction, which is when the ball's just rolling, or to show like you're rolling your finger across your hand. But if it's sliding friction, which happens when maybe the ball comes around a turn and hits the ceiling, and now it's spinning the wrong way. Now try to spin your finger the wrong way while you slide it. You can feel more friction rather than just rolling it. It feels like you have to work harder to get it to move. So that was a big problem. Once we got a track that worked, we tested to see if they took the same time. So let's do a test real quick. Got our handy dandy fly swatter to make these tracks run at the same time. So I'm going to put it like right, launch these marbles at the same time. One thing to notice right over there, there is a little pan. So you should be able to hear when the marbles come out if they're at the same time. Alright, so let's go 3, 2, 1, launch. You heard that they hit at almost the exact same time. It's pretty hard to graph or measure. Just hit at the same time. Like, yes, they hit at the same time. No, they hit at the same time. No, they didn't. Whatever. So we took each marble and timed them separately, one at a time, to test to see what the time was so that we could graph that too.